Hello world, and welcome to another video. Come for the education, but please stay for the motivation. Today's video is a continuation of our series on cracking the coding interview, and today we're solving a problem called loop detection. Feel free to pause the video to read through what this problem is asking for, but I find the examples a lot more descriptive. Also keep in mind that this also happens to be a LeetCode problem, to be more specific, LeetCode 141. Again, feel free to read this problem and make sure it's the same, but trust me, I took care of you guys and I already verified that it's the same problem. So let's go back to how we intend to solve this problem. But first, the example, we're given a list, a linked list, A, B, C, D, and C, where D points to the same C as before, okay? The same C as came before. We want to return that duplicate. Or a better representation of this problem is we can draw it this way, that 1 points to 2, points to 3, points to 4, and points to 2, where this 2 is not just a new 2, it's the exact same 2 here. So this is a better way of drawing it, where 4 cycles back. 4's next pointer points back to 2. Before we show how we're going to solve it, today's motivation comes from Jim Rohn, and I quote, "Don't wish it were easier, wish you were better." In life, you're going to encounter so many obstacles, okay? So many problems. The worst thing you can do is wish you had less problems in life. Never wish for less problems, wish for more skill, wish for more opportunity, wish for more strength, wish for more patience, for more perseverance, for the strength to wake up every morning and keep working until you get to your goals. Whenever you encounter obstacles in life, realize that on the other side of that obstacle is growth. It's a path to you becoming the better version of yourself, or the best version of yourself. So never walk away, never run away from problems, run towards problems and break them down. So back to the problem, pun intended. So here's how we're gonna solve it. We're gonna define a function. You can call him whatever you want, but in my case, I'm gonna call him hasLoop. So def has loop, and he's just going to check. He's going to take in the head of our list and check if this list has a loop in him. In this case, keep in mind that 1 goes to 2, 2 goes to 3, 3 goes to 4, 4 goes back to 2, 2 goes to 3. So we're literally stuck in a cycle, a never-ending cycle in this linked list. So we want to be able to detect that. So I'm going to I'm going to use a hash set, a hash table, in this case a hash set. So I'm going to call it, you can call them whatever you want. I'm going to call it scene nodes. He's going to keep track of all the nodes we've seen already. I'm going to start him off as an empty hash set. Okay, so what this looks like, what this empty hash set is going to look like is, let's create the empty hash set starting off. Okay, so now I'm also going to create a pointer, current. I'm going to call it cur. I'm going to set them equal to the head of my linked list. So effectively what this looks like is current pointer, point right here. Okay, let me go ahead and move this hash set a little bit down so we can have some space. So now we're going to check. As we go, we're going to iterate through this linked list, and as we iterate, we're going to add each of the values to this hash set. And here's how we're going to do. We're going to say while current is defined, while he's not none, okay? If current is in our set, if we've already put him in the set in the past, okay, that means he's the repeating node. We're guaranteed there's only going to be one cycle, right? If he's already in our scene nodes, we just return him. Else, meaning he's not in the scene node, we haven't seen him before. In this case, we're just going to add him to our scene node. So scene node dot add. We're going to add cur, and then we're going to move current forward equals, and boom, that's it. This is all the algorithm we have to do. But let's go ahead and walk through it and see what's actually going on. So in the first instance, cur is at the head, he's 1. He's not in scene nodes because scene nodes is completely empty. This is the empty set we created. So we're going to go to the else block and add him in there. So we're going to add node 1. Okay. So next, we're going to keep in mind we're adding 1. Technically, we're adding 1, 2, 3 because every node has a next pointer, right? Technically. So we're going to go back to the top of the while loop, and we're going to move current forward first and then go back to the top of a while loop. So cur is right here. Okay, then we're gonna check, is he in C nodes? No, he's not. Guess what we're gonna do? We're gonna add him in there. Okay, so at this point you get the gist. We're just gonna keep going. The first time around, everyone is gonna be new. We're gonna add them in there. Okay, so at this point, current is gonna be pointing right here after we add him. So now we're gonna have to move to current.next, and current.next is pointing back to 2. So current is gonna move back to 2. And now he's back to 2. We're gonna check, is he already in our C nodes? Yes, he is. He's actually this guy right here. Okay, so what we're gonna do is we're gonna close our set, and we're just gonna return this value. So let's go ahead and see what he looks like on our code editor. Again, I've gone ahead and created the node class, which is the building block of our linked list. Created our linked list class, which is how we build our linked list. Created our append class, which is how we append values to our linked list. Created our append node class, which is how we append nodes to our linked list. Created the display, which is just a function, not a method in the class. It's outside of the class, which is how we visualize and see our linked list. And now this is the actual code we just talked about. This is the code we just wrote on the white paper. So now I've created the node 2. And although he's set to a value of 99, let's change him to 2 first, okay? So now I've created my linked list with the values of 1, node 2, which is this node right here, value of 2, 3, 4, and then he's wrapping back around to node 2. So I commented this display on purpose, because let me uncomment him and show you what happens when I run him. So you can tell we're stuck in a cycle, okay? We're gonna stuck in this never-ending loop, like I said here. Just because this guy wraps back around, goes to 4, wraps around, so it's never gonna end, right? So I'm just gonna stop him manually. Okay, now we'll stop with the error, but you see how it goes 1, 2, 3, 4, 2, 3, 4, 2, 3, 4, 2, 3, 4, all the way to infinity, right? So let's go ahead and comment him. We don't need to see him. However, we're making a call right here to the function that checks if we have a loop, and we're returning the value. Let's see what it looks like if we don't return the value. We return the actual node object. So let's run it now. So now we've returned the node object. So whatever node object is at this memory location in my PC, that is the node that repeats, which is this node 2. Okay, now let's put the dot value in there and see what that does. So that gives us the value of the repeated node, which is 2. So let's change repeating node to any number, just so we know it works and you guys can have the confidence I'm not selling you guys snake oil. So let's run this. Okay, see the repeating node this time is 9944, and we can tell it works. Okay, so now it's a LeetCode problem. Let's go. This is the exact same solution. Let's go ahead and submit it. Boom, we pass. So that's it for the video, guys. I hope it was helpful, and I'll see you for sure in the next one.